In this problem, we're going to use the concept of upper and lower sums to estimate the area under the curve y equals the square root of 3x on the interval 0, 1. Now we're going to use equal spacing of delta x equals 1/4. So what we've done is we've split this into, well, there's 0, 1/4, 1/2, 3/4, and 1. So we have 4 intervals of interest. We have 0, 1/4, 1/4, 1/2, 1/2, 3/4, and 3/4, 1. Now what we want to do is we want to fill out the where we think the minimum exists, what the value of that minimum is, and then where the maximum, we think the maximum is, and the value of that maximum. Now, one thing we know from calculus is that if we take the derivative of this, we would get square root of 3 over 2x. And what we find is that for x greater than 0, that is a positive value, which means that that function is increasing on the entire interval. Excluding 0. So on the open interval 0, 1, that function is always increasing. So why does that matter? Well, what that means is that this function is what's known as monotone increasing. Why does that matter? Well, monotone increasing functions always have their maximum at the end point of the interval because it's always increasing. So on any interval, the maximum will be at the end point and the minimum will be at the starting point. That's just a guarantee from what we know about calculus. If it's increasing, well, it's always minimum because it's always going towards its maximum. Anyway, just something to be aware of. So if I'm going to take this interval, if I want to overestimate, I'm going to take the right-hand point. If I want to underestimate, I'm going to take the left-hand point. So in this case, it's actually a flat line here. I'm just drawing it under to emphasize that's a flat line, a flat line, a flat line, a flat line. So we see this underestimates it by quite a lot. So in this particular case, our minimum, let's keep the colors consistent. Our minimum is at the left-hand points. And our maximum is at the right-hand points. So if we take the function value, since I've already got blue out, at the maximum, that's going to be square root of 3 over 2. This is going to be square root of 3/2, which is different than that. That would be like the square root of 3 over 4. This is the square root of 9 over 4, which we could write as 3/2. And then this is the square root of 3. So if I wanted to figure out what the value of that sum is, what I do is I add each one of these, but I have to multiply by, those are the heights, but I have to multiply by delta x. So I would get square root of 3 over 4 times 1/4 plus square root of 3 over 2, 1/4 plus 3 over 2, 1/4 plus square root of 3, 1/4. So you have to, again, make sure that you multiply the function value by delta x. And then if you plug that into a calculator, you'll get whatever answer that is. Now, over here, what we have is, that's going to be 0. And we already know what it is there, so that's square root of 3 over 4, square root of 3 over 2, square root of, well, that's going to be 3 over 2. So notice that these are kind of staggered. And that makes sense because we're really getting the same rectangle just later, right? The same rectangle that was in this piece is in this piece. The same one that's here is here. The same one that's here is here. And that's just because we're using the left and the right hand points at different times. So the lower sum is 0 times 1/4 plus square root of 3 over 4 times 1/4 plus square root of 3 over 2 times 1/4 plus 3/2 times 1/4. So again, you could plug that into a calculator, get your answer to whatever decimal is appropriate, and you'll see that this is the lower sum and this is the upper sum. And for reference, that's probably a little too hard for me to do in my head right now, but there are plenty of calculators that will tell you the exact area under the curve there.